Hello once again, pre-calculus students. So we're ready for our final day of the week here, and we're going to be looking at 8.1. We're going to do our final time in 8.1, and so we're still working with parabolas, but we are now going to talk about proving that something is a parabola. And it's not a proof like what you're thinking of, like a trig proof at all. It's not like that. It's just basically getting it in vertex form to see that it's a parabola. That's all there really is to it. And then applications. So let's go ahead and let's take a look at these things and see how we're going to work with them. So first, we're going to talk what we mean by showing something or proving something is a parabola. It's really not a formal proof at all. All it is taking this equation. Notice it is an equation. It's an expression here with a number of different terms, some variable terms like y squared and minus 6x, and some constant terms like plus 13 and 0. It is an equation. We have an equal sign. And we want to demonstrate that this is a parabola. This is an equation of a parabola. And then we're going to do that by getting it in vertex form. And then we're going to find its vertex, its focus, and its directrix. All right, so let's talk about how we're going to get this in vertex form. So the key thing here is in the vertex form, what we want to have is we want to have the squared variable on the left side, and we want to have everything else on the right side. So what we're going to do is we're going to complete the square with that left side to obtain the vertex form. So I'm going to go ahead and start from here. And the first thing that I'm going to do, so this is my equation just as I see it. And then the first thing I'm going to do is I'm going to move everything. So notice the y is the squared variable. So all the y terms are going to stay on the left. The x is the non-squared variable, so it's going to go on the right side of the equal sign along with the constant. So I change this to 6x minus 13, and I leave this y squared plus 2. So all I did is I just rewrote it, okay? Just simply rewrote it, or rewrote the problem, and I just left a gap here so I could complete the square and move things to different locations. Now I'm going to complete the square here. This is a process we've done before, but I'll remind you again. We divide the 2 by 2. Divide whatever this is here by 2, so I get 1. Square the 1. 1 times 1 is 1, so I'm going to add 1 here. But if I add 1 to this side of the equal sign, in order to keep it equal, I must add it to the other side. So you can see here's a description if you want to write this down of what I did here. Let's put all the terms with the squared variable on the left, others on the right. So that's what I was doing there. So here I complete the square. Now this is my perfect square. This is y plus 1 squared. So simplifying this, I get y plus 1 squared is equal to 6x minus 12. Final thing I need to do is factor out the leading coefficient here with the x. So I'll factor out this 6, and I'm left with y plus 1 squared equals 6 times x minus 2. So that was my completing of the square, and there's my factoring the coefficient of x. Now I've shown it's a parabola. Okay, it's not a proof in that formal sense. It's just getting it into vertex form. I can quickly see it's in vertex form now. The y is squared. This is going to open up left or right. This is positive, so I know it is going to open up to the right. The x coordinate of the vertex is going to be 2. The y coordinate is going to be -1. So I know it's going to have its vertex at 2, -1. It's going to have a focal width of 6. So I can know all of these things. So here's my vertex. It's at 2, -1. Notice for my focus, what we do is we have to find our p. So I divide this by 4, because remember this 6 is 4p. So solving for p, I divide by 4. So 6 over 4 is 3 over 2. So I must go 3 over 2 to the right. So I add that to the x component, and that becomes 7 over 2, because 2 plus 3 over 2 is 7 over 2. -1, that's my focus. And the directrix, I go 3 over 2 in the other direction, So if I subtract 3 over 2 from 2, I get 1/2. So x equal to 1/2 is my directrix. Remember, that is a vertical line. So we have its equation, x equal to whatever value it is when it goes through the x-axis. All right, that's one type of problem you're going to have to do. The other type of problem you're going to have to do are some application type of things. So here's one that's really easy. Well, I don't know if I'll say really easy, but it's pretty easy. Find an equation from a graph. And they're going to keep it easy on us because they're going to show us the vertex. So long as they show us the vertex, it's pretty easy. If they didn't show us the vertex, then it would be a more difficult problem. But since they show us the vertex, here's an example, 56. We've got this graph given to us right there. So we can quickly select, we know it's one that opens up, so we can quickly select the correct form. So we know it's going to be the one where x is squared, so it's going to be x minus h squared equals 4p times y minus k. And once again, remember, to get the equation, I just need to fill in h, p, and k. H and k are very easy to fill in because I've got -1 and 3 right there. So -1 is the h, 3 is the k. So I can quickly do that. I'm getting very close now. Now all I have to do is p. Now, of course, the challenge to getting p here is they don't give me a focus, so I cannot figure out a focal length directly from that. But they do give me another point, this 0.35. So what I can do is, I know that that point, when I put 3,5 in, must make this a true statement because it's on the parabola. So if I put in 3 for x and 5 for y, I will get an equation that I can solve for. So I'll substitute 3, 5 in, and I can solve this for p. So looking here, it looks like I've got 4 squared, which is going to be 16, and this is going to be 4 times 2, so it's going to be 16 is equal to 8p, which we can see quickly p becomes 2, and that becomes my equation. Pretty straightforward. Hey, I don't think that'll give you too much trouble. Now, the last part will probably be a little bit more challenging, and those are the classic application problems. So let's look at a classic application problem. One thing about applications can help you significantly, and that's you can place your vertex or anywhere that makes it easy for you to calculate. So your parabola, you can have it open up, down, left, right. Put your vertex on the origin, put your vertex above the origin, whatever makes it work nicely. Usually, we're going to put the vertex at the origin. So if we look here, what we're told here on 59 is we're not given this parabola in the coordinate plane. Okay, this example, number 59, if I need to open up my book, I believe this is our flashlight example, but yes, so flashlights, and actually most any kind of directed beam light, so like the headlights in your car, anything like that, the back of the light is actually a mirror, because what we want to do is if we locate, and the mirror is always in the shape of a parabola, because if we locate the light right at the focus, wherever the focus happens to be, when that light shines out and it hits, and of course the light will emanate in all directions, but as it hits the mirror will reflect it out parallel to the axis there of the parabola. So it will reflect it straight out. The other thing that they do a lot of times with parabolic shape as a reverse are things like microphones or not telescope so much, but satellite dishes, things like that. Some sort of forms of telescopes too, where the images or the signals come in, hit the parabolic dish, and then it reflects it to the focus, wherever the focus happens to be. So it is very important to be able to locate the focus when we have something like this. So in this case, our flashlight, we're told that it has a diameter here of 6, if I look across there, and it has a depth, where that diameter is 6, it has a depth of 2 back to its vertex. And what it wants us to do, as you would typically expect, is it wants to know where is the focus. Where do I place that light bulb? Well, notice there's no coordinate plane given or anything like that, no equation. So I can put the parabola wherever I want to. So I picked what I thought would be the easiest place. I put the vertex at the origin. That makes h and k 0. And notice what I get then is if I want to get an equation for this, I've got the vertex and I've got a point that's on the parabola. Because if this has a width of 6, it will be 3 away from the y-axis. So the x-coordinate will be 3. And if this has a depth of 2, if this is located at the origin, then I know this is going to have a y value of 2, so my y-coordinate is going to be 2. So I can go ahead and do just like I did on 56. I'll start with my vertically opening equation, put in the origin for my hk, and then I'll simply substitute in 3 for x and 2 for y and solve for p. So I get 9 is equal to 8p. Divide both sides by 8, and I get that p is 9 over 8, or decimal 1.125. So remember, that's the focal length. So it says the focus is 1.125, in this case it's centimeters, away from the vertex. So that would be my final answer. The bulb should be placed at 1.125 centimeters from the vertex. Notice, you could say 8/9 centimeters from the vertex, but normally we don't measure centimeters or inches or anything like that in those fractional forms. Usually we'll give them as decimals when we're answering application problems. Okay, so that's the material for today. The homework is 49 through 56, all of those, and then 60 and 64. So it is a little bit shorter assignment, but there are some of the problems take a little bit longer, but I don't think it should take you too long. So yeah, have those done. These need to be done by Sunday night, so it's our typical like a Friday assignment on the weekend, not due until, you don't have to have it done until Sunday night before you would be heading to school on Monday. So make sure you get all that done. I hope things are going well. If you have any questions, you can shoot me something on Google Classroom. If you need some personal help with stuff, you can talk to me. We can even set up a personal Zoom session if that's what you need, and we can go from there. Hope you guys have a great weekend, and we will plan on having our next Zoom session on Tuesday to answer any questions that you've got on this, and hopefully I'll have all your homework from this week. I don't make promises about the test, but hopefully we'll start to see the grades, at least on the homework, done by Monday, maybe even the test. Who knows? All right. We'll see you guys.